extend this vector a little more. So if this angle is phi, this one from here to here, that's phi. What is this angle?
Phi minus d phi.
Okay, and since d phi is tiny, it's essentially phi,
Oh,
right? It's still phi. Yeah. So that's phi. Okay. And so what is this angle here?
okay.
90 minus phi, yeah, 90 minus phi, yeah, it is. 90 minus phi. You see, the d phi is so tiny, I just needed to calculate the ds, but the phi itself essentially stays unchanged. So this is 90 degrees minus phi, okay? All right, are we good? Okay. So how much work is done? So let's see how much work is done. dW plus, I'll put dW plus meaning the work done on the positive charge. And will be that same amount of work done on the negative charge, okay? So it's the force. Remember what the work done is always force dotted with displacement, in this case ds, right? F dot dr, dr I'm calling it ds. Now what's the force on a plus charge in an electric field? QE, yeah. So it is Q times E, the electric field, QE, okay? Let's do it in 2 steps or 3 steps, dot ds. Now ds, well, let's leave it as ds first. Now, I'm taking the dot product of 2 vectors. So they're, the result of the dot product will be what? When you take a dot product of 2 vectors, you get the magnitude of the first vector times the magnitude of the second vector times the cosine of the angle between them, right? What's the magnitude of my first vector? That's my first vector. Just QE, yeah. Q times E. Okay. What's the magnitude of my second vector? How large is ds? So here is I'm exaggerating again. So if this is d phi, here is ds, and the distance, what's the distance from here to here? Well, it's, if the distance between the 2 dipoles, we usually call it d, right? So distance between 2 dipoles, or s?
Yeah,
I think d. Yeah, so the distance from here to here is what?
d over 2.
Yeah, d over 2, so d over 2. So what's the relationship between this?
D over 2 times d phi.
d phi, yeah, it's the arc length. Remember, for let's say you have an angle theta. This is r, and this is ds, or you can, yeah, if this is d theta, this is ds. R d theta is equal to ds, right? That's how you calculate the arc length. So in other words, ds is d over 2 times d phi, right? So it'll be d over 2 times d phi, and left extra space here for a reason. And then times the cosine of the angle between them. What is the angle between them?
D theta.
The angle
Or
between
90
90 minus phi, yeah. Because E is this way, ds is this way, so there's a 90 minus phi between them. So 90 degrees minus phi. Now d phi, because I'm talking about magnitudes here. So the magnitudes have to be positive. So d phi, is it a positive thing or a negative angle? The angle increases if you go counterclockwise or clockwise.
Oh, okay, so it's negative. I know it's
Yeah,
negative.
so if you go counterclockwise, you're increasing the angle, so it's positive.
Is it a
If
negative?
you go clockwise, it's negative. So d phi itself, in this case, it's negative. So if I want it positive, what do I do?
Multiply by negative.
Multiply it by by a minus 1. So that would be, so that's the annoying minus sign. that-
Oh, okay.
Can you do that?
Huh?
Can you do that?
Yeah, so let's say this is 0, right? If I rotate this way, that'll be positive 30 degrees. Let's say this is, if I go this way, That's positive 30 degrees, let's say, okay?
Okay.
But what if I go this way?
That's fine.
Minus 30 degrees.
And that's fine.
Yeah, that's why there is the minus.
Where'd you get the D over two from?
Is the distance between the plus and the minus charge. So, from here to here is D, so from here to here is D over two.
So that's your DS? Oh, where's your DS?
My D, yeah, this is D.
Oh, D, just distance time.
Yeah.
Oh, okay.
Oh, this is the differential, this is DS is in like DX or DY. Yeah, sorry, the letters keep piling up, yeah. And, well, let's see if I can do this in a second. Cosine of 90 minus phi is what? Sine, right? So I got negative Q times E times D over 2, right? This minus is from here, and then sine of phi. That's dW from the positive charge, and the field will do an equal amount on the negative charge also.
Okay.
So what's dW total? Would
Possibly.
be dW from the positive plus dW on the negative charge, right? dW on this negative charge. So when you add them, you will, just the 1/2 goes away. So just the 1/2 goes away, and you get negative Q E D sine phi minus Q E D sine phi. And one more thing, what is Q times D?
Oh, the dipole moment?
Dipole moment, yeah, that is P. Remember, dipole moment is QD, right? So this will be minus P times E times the sine of P. And to get the whole work done, you have to,
Where did D phi go?
Where did D phi go? It didn't go anywhere, it should be there. D phi. You know what, I think I'm rushing a little bit. Let me start fresh on Tuesday with this. I'll do it Tuesday. Yeah, I don't wanna rush it. Yeah, so we will start with this, okay?
Kind of makes sure that.
Yeah, we will start it over.
Not really.